Today we'll be looking at the jump if not equal operation in assembly, and I'll be showing you how to use it. So let me open my editor. So nano, I'll name it jne.s. Then as usual, we'll go ahead and set up our assembly file like that. So the section text, then define the global start, then start our label over there. So in the previous video we saw how to use the compare keyword, but let me do a refresher. So let me move some numbers into some registers. So I'll move 12, I'll move bx, maybe the value 11. Then to compare, you just use the CMP keyword followed by the destination register and the EBX or the other register that you want to compare with. So, and in the previous video we saw that you can this compare operation will do a subtraction behind the hood. If the subtraction is 0, it will update some flags which are called E flags. In particular, the 0 flag will turn to 1, and if the result will be a non-zero or anything that is not 0, the 0 flag will again switch to 0 again, because now the operation has resulted to a non-zero. Now, and we saw to handle maybe some cases we used some conditional jumps. So conditional jumps like that. So when we saw one in particular, which was the JE, meaning jump if equal, then we defined some labels over here. Maybe we wrote an equal label, then we did a system right, and we saw only this conditional jump. Today we'll be looking at the jump if not equal. So in the case that these values are not equal, we'll now define another label that will be executed if the operation over here is not equal. So let's go and let us define this is the equal one. Let us define another label. We'll name it not equal. And what they will do typically, they will just print something in the standard output. So we'll be using some strings. So we'll be using the section data to define some strings. So section data. Then I will name MSG1. I define 1 byte. This will hold the value equal. Then let us terminate it with a 0. Then we give it a new line using the number 10. This meaning in the ASCII table, this is a line feed or a new line. Then we'll get the length, MSG1 len. Then we will use this shortcut for this trick. So the value MSG1. Then we'll define again our message 2 that will just say not equal. Okay, null terminate it with a 0. Then use 10 for line feed. Then MSG2 len, we'll use the quit, then $, then MSG2 like that. So we have defined our string constants. So let's go ahead and print something in this label. So in the equal label, we'll move as usual into EAX value 4. This is the system right. Then we'll move EBX value 1. So this is the file descriptor, meaning we want to print to the terminal. So ECX the pointer to the data we want to print, so it's message 1. EDX expects the length of the data being processed, so msg1 len. Then again we do an interrupt over there. Again we'll do the same over here, so move into EAX 4, move to EBX 1, move to ECX MSG2, move to EDX MSG2 len. Then we'll go here and maybe let us define an exit label where we'll be exiting, so move to EAX 1 for system exit, move to EBX, now the return status code, then again do an interrupt over there. Even here we'll just do an interrupt. So if the operation is equal, so the jump equal, so this means jump if the comparison above here is equal, and we'll use our equal label. Then the second one, which was the aim of making this video, this is the jump if not equal. So if this operation is not equal, as you can see, we say that let it execute the not equal label over down here, so this one over here. So if it's equal, it will execute this, and if it's not equal, it will execute the not equal part. So let me save, let me assemble it. Nazam dash elf elf 32, then the name of our assembly file, then we generate an object file. It has assembled, and let me link it. So dash m elf i386 followed by the name of our object file, which was this one, followed by now the O flag for our binary, so we'll name it JNE. So as you can see, we have our binary file over here. Let us try and run it. So we have a not equal. So let us change something here and see. They are not equal, so let me put maybe 11 and 11. So this will be equal, and try to recompile it again. Link it. So there is something that has happened over here. So it prints both the statements. So let us see why this is happening. So if this operation results to a 0, so meaning they are equal, and the first jump, conditional jump, the assembler will see will be this, the equal part, because if we subtract 11 and 11, it's a 0, meaning that these values are equal, so it will fall to this label. Then after jumping to the label, the equal label over here, you see it's the first label that we have defined, so it will execute, then after that it will resume back to normal, it will resume back to normal compilation or normal running of the instructions. So it will, after finishing this, it will see down here there is something that we have to execute, so it will go ahead and execute also this. So remember in the last video, if you don't want this to happen, so after this happens, we have to short circuit it and jump straight to the exit, because we don't want to execute this below over here, because if this statement is true, there is no need of running the second statement over here. So because, as you can remember, I told you like the assembler, the assembly language compiles code from top to bottom. So after finishing this, it will go ahead again to the bottom part until it reaches the end. But to do to short circuit that, we'll use the jump, then exit. So after doing this, there is no need of going here, so we will force it to jump to the exit label down here. So let me save. Let's try and compile it again. Then you can see now we have the expected behavior. So let us change again. So you have to play around with this. Maybe you can put the value at 21. See that if it behaves correctly, then if we run it, we get only one response. So that's the tricky part about using this conditional, because if you have defined a label, the label that you have defined and the assembler has jumped to execute, and you have not short circuited it or jumped to another memory location or label, it will assemble or it will run your project from top to bottom, meaning it will execute even this part that you don't want it to execute. So if this has been helpful to you, just leave a like, subscribe, and if you have any question, you can ask me on the comment section, and I'll be happy to oblige. Then I'll be creating a Discord server very soon, and I will notify you when I have created the server, so that we can interact more over there. So that has been all about the jump if not equal. So the key takeaway was this jump if not equal. So if the operation and the comparison is not equal, so this J and E will be executed. So that was all, and see you on the